Good morning, everyone, and welcome back to the second day of our 5 days faculty development program, ICTEA 2025. I hope you all had a wonderful first day filled with new insights, ideas, and connections. Yesterday, we set the stage for an exciting journey of learning and growth, and today we are going to take it to the next level. So let's get started. Today we have with us Dr. Swagatam Das, who will enlighten us with his knowledge and expertise. Please join me in welcoming Dr. Swagatam Das. Now let's have a brief introduction of our esteemed speaker. Dr. Swagatam Das earned his BE in Electronics and Telecommunications Engineering, ME in Control Engineering, and PhD degree from Jadavpur University, India, in the years 2003, 2005, and 2009, respectively. He is currently a professor at the Electronics and Communication Sciences Unit of the Indian Statistical Institute, Kolkata, India. He is also serving as the professor in charge of the Computer and Communication Services Division of his institute for the term 2024 to 26. His research interests encompass deep learning and non-convex optimization, and he has published over 400 research articles in peer-reviewed journals and international conferences. Dr. Das is the founding co-editor-in-chief of Swarm and Evolutionary Computation, an international journal by Elsevier. He has served or is currently serving as an associate editor of several prominent journals. Dr. Das received the 2012 Young Engineer Award from the Indian National Academy of Engineering (INAE) and the 2015 Thomas Router Research Excellence India Citation Award for being the highest cited researcher in engineering and computer science in India between 2010 and 2014. We are privileged to have Dr. Swagatam Das with us today. Without further delay, I request Dr. Das to begin today's session. Please, sir.
Good morning again, and thank you for this opportunity to share with you some of my experiences of our journey over the navigating over this extremely transformative landscape of generative AI. In next 1.5 hours or so, we will give you a 360-degree view of this landscape, especially in context to large language models and vision language models, their fairness aspects, what they can do for us, their translational capabilities, and some futuristic issues that need immediate attention. So I start almost from scratch, developing these ideas one after another. If you feel like you have a question, please interrupt me and ask that. So we know that the traditional machine learning area experienced major changes since 1980s, and a pinnacle of success in this particular area, given their huge multitude of applications in diverse domains of science and technology, appeared since 2010s. And the domain transformed into something that we call deep learning. So what does deep learning offer to us? What is their biggest advantage or biggest selling point? Let us try to understand that in this just one slide. So the upper picture A is the traditional machine learning cycle, where machine learning is like an engine and its fuel is, of course, data. Data is an abstraction of all real-world objects around us. Anything and everything that we can abstractly represent, store, process by a digital computer in terms of certain numbers sitting together as a vector or scalar or matrix or tensor or graph qualify as data. So this input is such an abstraction of a real-world object in terms of certain numbers together. These numbers that together identify or represent an object are called features, okay? And they are measured over the object they are basically measurements, different types of measurements done by sensory equipments. Uh, just like a camera takes a picture and all pixel values inside are the measurement of brightness of different points, they qualify as features. Now, one major question in the domain of computer applications for last 40, 50, 60 years had been how to most optimally represent complicated items of data, like an image, a text, a video, an ECG signal, in terms of most important, distinguishing, informative, and higher level features. Higher level features are those which are closer to human interpretation, like high level programming language. On the other hand, lower level features are those which are captured by a sensing device, like simple pixel values. Now, in traditional machine learning cycle, you have measured features which could be huge in number. In 1 megapixel camera image, you have 1 million such pixel values. Then there is a human feature extraction module, human intervened feature engineering module, where by some handcrafted, mathematically guided methodology, people try to combine these lowest level features to get hold of more abstract and higher level features. These higher level features should give us an improved representation of the input object, and then they are plugged into a statistical classification module or a machine learning program, which, based on these features, categorizes the input object into one of the pre-specified categories. If the input object is an image of an animal, then this classifier can tell us whether it's a cat or dog or hippopotamus. But there is no universally well accepted representation learning technique which can always extract most optimal, appropriate, and informative features for this representation. Deep neural networks get us rid of this manually intervened feature engineering. Deep neural networks, their biggest selling point is they can learn the appropriate representation and then classify almost without human intervention and through an end-to-end trainable system. Deep neural networks are this sort of, you can see picture B, this sort of a layer-wise connected, simple mathematical processing nodes which are layer-wise arranged and interconnected through these links, each of which has a weight on it. And the inputs are basically the lowest level features. Then while flowing through these links like electrical signals, these lowest level features gets amplified, attenuated, and combined in various manner to give rise to higher level and more human interpretable features. Then the classification is automatically performed and the context is also learned from the objective of classification. In fact, if you change the context, everything will change. I go to a bank, I ask for a loan, a file opens up in my name, and I start being specified in terms of my financial parameters, credit rating, CIBIL score, annual income, fixed deposit amount, and so on. Uh, if I change the context, I go to a blood bank and try to become a potential blood donor. Same person, me, but the blood bank starts specifying me in terms of completely different sets of parameters, whether I have thalassemia, whether I have blood glucose, sorry, what is my blood pressure level, and so on. Similarly, deep neural networks, so you change the context and the most important features that distinguish you will also change. Deep neural networks can sense the context of classification and then they perform the context aware feature extraction before classification. And that makes the task of classification much, much easier and more accurate. This is the biggest selling point of deep neural network, and these networks were proposed long back in, actually the rudimentary knowledge of these networks emerged from the works of John J. Hopfield and in 1982, followed by continual efforts of Geoff Hinton and his team, and this duo They won the Nobel Prize in Physics in 2024, as we all know. Now, coming to the modern area of deep neural networks, as they have also been evolving at a rapid pace, now we have two very prominent deep inference models. One we call discriminative or predictive inference model, like the convolutional neural network. I'm sure all of you have heard of it. They learn the most optimal representation of image type data. And so, for example, cat images are represented as these orange dots in some abstract higher level feature space, while dog images are represented as blue dots in similar feature space. And once this context aware representation of complicated data items like images are learned, CNN is happy to determine a decision boundary between the two classes. So most often this decision boundary could be simple, even a line for well-behaved classes which do not overlap much. So while once it learns this decision boundary, it knows that, okay, any point from the left side of this boundary is a cat's image and from the right side is a dog's image. That's all. On the other hand, there are neural network modules used as generative inference model. What are these generative inference models? So, for common people like you and me, data is just an abstraction of a real world object. On the other hand, for a statistician, data is an instantiation of a multivariate random variable that is fluctuating following some rules of probability. So all the images, all the text, they are samples from an underlying multivariate stochastic process, which is governed by certain rules of probability. Deep generative models, they don't, I mean, they don't emphasize on the task of classification. They rather try to estimate the underlying multivariate probability distribution from which data from different classes might have or most likely to have been sampled. Every data item is a sample from an underlying random process. So in this endeavor, if they can even approximately estimate the underlying spatial probability distribution of the cat's images and the dog's images, in the next phase, they can actually themselves sample from this approximated distribution. Do you know what does that mean? Sampling from this distribution means they can generate artificial but very, very realistic images of camera, as if camera clicked images of cats, dogs, rats, human beings, whatnot. Not only image, they can this way synthesize artificial but extremely realistic videos, text documents, fake profiles in Facebook, whatnot, speech, anything. So that is basically the idea behind generative deep neural networks or generative models. So nowadays, this term Gen AI has become an umbrella term for machine learning systems which are of large scale and the backbone of which are always deep neural networks that I showed almost in the first slide. So these generative AI learning algorithms, they can always produce new content based on instructions from the user. 20 years down back from now, we used to interact with the computer in our in C, C++, Java, etc. Now we can do it with our human speakable language like English or even Bengali. ChatGPT 4 is quite good at it. So this instruction from a human being comes in human speakable language. Now we call it prompt. Okay, an extremely important word for what we are going to discuss now. And the result from the Gen AI systems are indistinguishable from human generated contents or human camera clicked photos if the system is good enough. So they come with great responsibility and they are very much susceptible to misuse. So they should always be, marketized and used by the mass under human oversight and control. If they can be used with proper responsibility, they offer lots and lots of benefits, some of which we will see. So the input is basically a human instruction or prompt. This is one such big generative AI model, LLM, we will discuss at length. This is called large language model. And the output could be text, code, image, audio, anything. In fact, LLM, this term has also become slightly backdated. Now we call them VLMs or vision language models. So this is what is happening inside generative AI. Now, if we look back just to get an idea, what happens inside these models, if we look back to a first generation generative AI model called Generative Adversarial Networks or GAN, they have already taken backseat. So that's why I'm calling them first generation model from 2014. In fact, GAN includes two neural networks. Every neural network could be seen as a function y equal to f of x. X is the input, y is the outcome from the neural network. Inside GAN, there are two such neural networks. One we call a generator. Input of the generator are random noise vectors of 50 to 100 dimensions. These vectors are sampled from an extremely simple distribution, which could be uniform or multivariate unimodal Gaussian. The generator converts these vectors into matrices or images. So generator's input is a random noise vector, output is a matrix in the form of an image. On the other hand, discriminator is another neural network whose input is an image and output is a continuous scoring function between 0 and 1. Discriminator has access to a big set of real world images of some particular genre, some particular class. Maybe the head and shoulder image of film celebrities, something like that. So the discriminator is trained on very bad images initially generated by the generator when it is untrained and very good images from the real world. The discriminator is like the teacher. First, it is trained to know the difference between good image and from the real world and bad, extremely poor, ghostly images coming from a novice student, like the generator. Okay. So the discriminator first sets its standard. Once the discriminator is trained, it's like a two-class classifier. If an image comes to its input, if it feels that image is very good, it will assign almost one score for the image, and if it feels the input image is very poor, it will assign almost a zero value as score for the image, right? So at first, the discriminator is trained, its standard is set up, and then based on the feedback of the discriminator, the generator parameters, learnable, trainable parameters inside the generator function, which is a neural network, are modified, tuned, optimized. So the generator improves its image generation capability and generates better real world images. And these two neural networks, this way, engage into a competitive tug of war. In the language of game theory, we say they are playing a two-player zero-sum game. Okay, so the generator, the discriminator is there. It knows how real-world images look like. It has access to real-world images. The generator tries to fool the discriminator by creating fake images. The discriminator tries to catch up the generator by assigning these fake images as low score as possible until the generator has really improved and creates more realistic image, and this competition goes on. There are several theories how they will gradually settle down or reach some equilibrium point. But when the GAN's training converges and the generator is well trained, it can really create very much photorealistic images. So what you can see here is when GAN is trained on MNIST data and it is creating its own version of handwritten digits, starting from complete noisy pixels all around. It is arranging the pixels suitably to mimic human handwritten digits. And this is how the GAN images evolved over time. In 2014, when GANs were first proposed, NVIDIA didn't make its RTX GPU series. We didn't have the comfort of using, several GPU cores in parallel and so on. But as the hardware capability enhanced in subsequent years, you can see the 2018 big GAN image of this lady. So you can see the wrinkles, the gray hair, all details in her face. This lady doesn't exist. This image was never shot with a camera. It was synthesized by generative adversarial networks. And then gradually people tried to see how they can further modify and develop things on top of GAN. They said, okay, the generator is synthesizing images in batches. Why not constrain them? I want to generate human face images of males. All these males should have specs and should have French cut beard. How about that? Or should have nice mustache. How about that? So from this conditioning or constraining the outcome of the generator came the conditional GAN or CGAN, conditional generative adversarial networks. And then there was an input image, there was a ground truth, and there was a predicted image. So the input image, ground truth, and predicted image. Ground truth was used to, modify the constraints on what the generator generates. And as a result, if the input is a nighttime image of some landscape, and if your conditioning image is a daytime image, then you can convert the input nighttime image into a daytime image, or input winter landscape into summer landscape. Okay, so I was talking about image to image translation. When you are translating the style of one image into another image, keeping the content of that target image unaltered. So you see, basically the horse is becoming a zebra, or you can import the environment of PUBG game into Fortnite game and you can create a new game, as you can see here. This soon spread it into other sort of data like speech. Vocal style transfer became very famous in the speech and audio community, where you can have this dialogue, this session lectured in my content, but the voice could be from Mr. Amitabh Bachchan. So such vocal style transfer became very common, and now it plays a huge role in dubbing industry in movies, because you don't have to fly a star from South India just for the purpose of correcting the dialogues or dubbing. You can create that voice, the vocal style, and the content could be from your script writer. That's it. So, can you hear me? Hello.
Yes, sir. Yes, sir. Sorry.
Hello, can you hear me?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. So that way came and gradually this work spread into more abstract style transfer. For example, we came up with a special loss function, Gromov-Wallenstein loss, which was inspired by the optimal transport based losses. Optimal transport is a typical way of converting one probability distribution into another probability distribution. We used it inside capsule networks proposed by Geoff Hinton in 2017, and we came up with a capsule GAN-based style transfer network which could handle more abstract things. Like the black and white marks on the zebra are quite explicit, but we wanted to translate more abstract, more implicit facial expressions. So you can see the facial expression of this male actor has been translated into the female actress faces, and you can see the way the two eyebrows are looking, how they shape up in these translated faces. Or maybe even more abstraction is here, where the cold stare of the cat has been translated into these dogs' faces by using disentanglement from the generative equivariant networks. This is a video which is not playing up. So this video shows how Dev Patel's face change if the style, no, how this female actress's face change if Dev Patel's facial expression is imposed on this face. So you can see the constriction around the lip region, and you can see that's how the expression is disentangled from Dev Patel's face and then superposed on this face. We did a work of synthesizing artificial samples inside a minority class to populate the minority class and balance the size of the classes in an extremely imbalanced classification situation for image classification. Imbalance is a huge problem in for machine learning community. You have two, three classes, and one class is severely outnumbered by other classes. If you have maybe several classes, more than 300 classes, and many classes have very few samples compared to other classes, then we say the data follows a long-tailed distribution. This is multi-class imbalance. And to circumvent such problems for image classification, we used a three-player GAN architecture called GAMO. And this GAMO is called Generative Adversarial Minority Oversampling Technique. This GAMO can create, so you can see two unbalanced classes here, and the decision boundary by the neural network is typically biased towards the majority class, and it misclassifies several points from the minority class. So for example, if you scan the lung X-ray images, you can see pneumonia or maybe lung cancer traces in very few people, 4 out of 100. But those 4 people are very important. They must be isolated from the rest healthy 96. If your machine learning system classifies all of them wrongly, then its accuracy would be 96% because it has classified 96 healthy people as healthy, but its usage would be negative. So GAMO creates this sort of green points. These are extra points inside the minority class, and then they also spread these green points well within the periphery of the minority class, so that the decision boundary between the two classes, as learned by the classifier, becomes unbiased and more, you know, uh, extensive. Okay, more extensive between the two classes. So this is what GAMO doing, and I will not explain it any further because all everything and including the codes are available here. This was also published in ICCV 2019. Now the state of the art for image generation has shifted from GAN-like networks to diffusion models. And diffusion models could be said to be the most cutting edge generative frameworks, and they can create stunningly realistic images by a simple process of forward and reverse diffusion. So during the training, what they do is they take up images and images from real world, and then they go on adding Gaussian isometric noise into these images in steps, okay, until the image becomes completely noisy, losing all its structures. So the isometric noise is added into the image until the image becomes completely noisy. And thereafter, the image is denoised by removing the noise gradually from from the image. So once the image is denoised, this denoising happens by using neural network structures like either UNet or denoising autoencoder. And these forward and backward steps happen over many, many images. Once the training is completed, now you take up this sort of an image, this sort of a completely noisy image, and you go on removing the noise in steps from this image. Once the image is completely denoised, you will get back this sort of a original denoised image of something which belongs to the same genre of images, maybe cat's images or maybe human head and shoulder images, but not a carbon copy of any of the input image. It's a new synthesized, artificial, but realistic image. And that is the expected outcome from any generative model. All generative models during training will be shown examples of real world images, and they should then give us or synthesize for us images which belong to the same category of real world images which have been shown to it, but not an exact carbon copy of any such image which was shown to it. So diffusion model operates in this way, and they form the backbone. Stable diffusion models form the backbone of DALE 3, Mid Journey, this sort of uh, image generators that come along with uh, ChatGPT 4 like chatbots backed up by large language models. So they operate on the basis of this philosophy from Michelangelo that the sculpture is already within the marble block. Only thing the artist need to do is to chisel away the superfluous material. So as a similar analogy, the entire cat's shape and its surroundings are hidden inside this noise. So you need to remove the noise suitably so that it gets converted into nice actual image. So now you have seen how generative AI is evolving. Now let's look at how the landscape of ML is evolving. The traditional ML, which statisticians and computer scientists started to look almost 20 years, I mean, not 20, sorry, almost 50, 60 years back from now. Uh, that was task specific machine learning. You train a machine learning model for performing a single task. And once, so you have medical images, human lung X-ray images, and you want to classify them into benign or malignant, cancerous, these two classes. So you train a machine learning system with several such images initially labeled by a doctor, and the machine learning system puts each new image which comes to it after training into one of these two classes, Kolkata. Then again, you need to classify between bank transactions, online transaction records, whether they are genuine or fraudulent. So you take each transaction record and you have to put it into one of the two possible classes. You train another neural network or logistic regressor or naive Bayesian classifier, something like that, for that task. And again, Kolkata, when you need another task to perform, maybe regression or another classification, you will train another system from scratch. And no experience or knowledge is retained or accumulated. Learning is performed every time from scratch. Then the machine learning system is deployed and it's the end of it. But human life, human learning is not like that. You may have switched your jobs in your career. So at this point of time, you may be a professor. Before that, you may be a researcher in some R&D company. Before that, you might have done some apprenticeship or internship for some other company. All these experiences are accumulated in your career, I mean, in your brain, in your activities, And later on, when you perform some other job, these experiences will help you a lot. So our normal learning cycle operates in that way. Can machine learning systems adapt that? From this point of view came transfer learning. Transfer learning was all about learning of new tasks, relying on the experiences gathered from previous tasks. So a machine learning system is trained on demarcating between large trucks and small cars and vans and cycles. After this training is over, the machine learning system, with very little change in some final layer weights, could be adapted to distinguish between large elephants walking on jungle versus small animals like deers and rabbits and so on. Because it has seen similar data, it knows the truck is very big and its shape very vaguely resembles a big elephant walking. So that experience will help the machine learning system to adapt itself for the classification between large and small animals also. That is transfer learning. Nothing new. Transfer learning existed since 1980s or so. What is new is here. Now we are even going from transfer learning towards foundation models. Foundation models are massive multitasking machine learning systems which are actually trained on huge amount of external data. They are very much multitasking and they can offer a variety of versatile outputs. Like in classical NLP tasks, they could give you question answer sessions. You ask a question, it answers. It can translate a paragraph from one language to another language. It can fill in the blanks. It can uh, create sentences with the words that you specify and so on. So, foundation models are the names given to massive, versatile machine learning systems which are adaptable to a wide variety of tasks with almost little or no training. And they are usually trained beforehand, they are pre trained on a huge amount of external data. For example, in image segmentation, many of you might have heard of image segmentation or might have worked on image segmentation. By the way, am I clearly audible?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. So now, image segmentation, people have used several mechanisms for segmenting images by optimization, by neural network, by region growing, splitting, merging, this sort of methods for a long time. Now everything has become obsolete and image segmentation is entering into a foundation model. So this is called SAM. Okay, SAM stands for Segment Anything Model, a foundation model for computer vision. You have this model here, and you can specify the things to segment either by specifying some coordinates on the body of the object to be segmented from the image, or by specifying a bounding box, or by specifying abstractly the region where this particular body lies, or by simple text prompt like cat with black ears. So this is your input image. In this input image, there is a cat with black ears. You give this input to SAM. SAM stands for Segment Anything Model. It's a diffusion-based huge neural model for foundation model as for segmentation. And you specify this text line, cat with black ears, and this output from SAM will show you an image where this cat with the black ears have been segmented out. That is what SAM does. You can now adapt SAM for various application purposes, but SAM was published in ICCV 2023. I do not see the full citation here, but you can search anyway, and the paper is very famous. Now, we have seen that deep generative models had been mainly used to generate synthetic data which can be used in different applications, like to avoid class imbalance problems in several real life classification, text to image to image conversion, image in painting, super resolution, synthesis of speech and music, dubbing, as I said, computer graphics, rendering, texture generation, character movement. And when we just started to think, okay, the machine learning community is about to saturate, AI has reached its stage of saturation, then suddenly another boom came with the introduction of ChatGPT, which is not a language model, but which is an interface between the large language model GPT 3.5 and its users. So OpenAI in November 2022 launched ChatGPT, and that gave a major thrust to the AI community. It almost took the entire world with storms. And people came across the term LLM, although LMs or language models existed for a very long time. Even in 1960s, people could see chatbots like Eliza and so on. But the LLM was a completely different ballgame. They had huge, enormous capability, and we are still exploring how that capability could be expanded in several real-world application corners. All language models, large language models specifically, they are huge neural networks based systems which can interact with users by pretending that they understand the syntax and semantics of a human speakable language. These neural networks or large language models operate on the basis of the quote that you can see at the bottom of this slide from John Farth. The quote says, "You shall know a word by the company that it keeps." What does that mean? Unlike human beings, computers are not fitted with sensory organs, right? They cannot feel the words organically like we do. If we hear the term red mutton curry, so a nice dish, picture of that nice dish, red Sunday mutton curry with aloo, flashes in our inner vision, in our inner eyes. We can smell it. Our, tongue becomes salivated. But the computers cannot do that. So how they will understand the meaning of red? What they see is they have a vocabulary, they have huge memory storing many words as text tokens. So they see with what other words the word red is sitting. Red idea, red fire truck, red riding hood, red book, red mutton curry. What are the other words with the word red is sitting? Compositionality of red with other words, and frequency. How frequently red is sitting with the other words, that also it takes into account. And as a combination of these two, in the machine memory, a quantitative meaning of the word red is somehow formed. So every word has very close drawn neighbors which very frequently get composed with that word. And from these neighbors and how frequently this word is sitting with its neighbors, a quantitative analog of meaning of the word is grasped by the machine. So that's why I said it pretends that as if it understands the semantics. Understanding the syntax is easy, but understanding the semantics by a computer is an extremely difficult task. It does it with huge computational power and by following this principle that I just mentioned. So large language models allow us, arguably, to walk with baby steps towards what we call artificial general intelligence, or AGI. So from AI to AGI. See, in 1950s, 60s, 70s, when the traditional programming came and started to dominate the world of computer science, it was all about there is a smart human being who has set up certain rules, and the computer, just like a dumb clerical person, matches against these rules and infers something about an input. If the input is an image, the rule may be okay. If the animal has four legs, 2 ears, if the animal has fur, if the animal likes to take yarn and catnip, then it's a cat. So the computer sees the animal's picture and matches against these, attributes. Once it finds these things are okay, they are obeyed, then it infers it's a cat. And this was traditional programming. Then there came the wave of neural networks. Everybody talked about AI. PIC came in 2012. What was this revolution all about? It was about, okay, I will show 1,000 cat images and 1,000 dog images to my neural network. The neural network will automatically understand what are the major differences between these two classes. Then the neural network will encode this knowledge inside its weights and biases, and then as a new image comes, the neural network will exercise this acquired knowledge from the previous examples, and then it will categorize this new input into one of the two classes. This was neural networks. Now there comes the generative language models, Lambda, Palm, GPT. What is the difference here? Suppose you are a very motivated teacher, okay, and your student comes to you, asks you a question, how to distinguish between cats and dogs, let's say. And you are a motivated teacher, you don't believe in spoon feeding. So you will not tell your student 9 questions out of which 7 will come in the semester exam. You will take your student to the library, put him in front of a big almirah full of books, and you will say, look, you wanted to know about cats and dogs. This almirah is full of books on taxonomy, evolution, etc., about the animal kingdom. You read all of this, then you come back to me and I will ask you questions. And you leave. The student has two options. Either the student can run away and never come back to you, or if the student is equally motivated, he can burn his midnight oil, read all those books, and come back to you. Then you can ask him any question. He has a lot more information to give to you about animals. Okay. Similarly, large language models are neural networks which are initially pre-trained in an unsupervised manner over the entire text repositories available on internet, including Wikipedia, PubMed, and so on. So the neural network is initially trained on such text repositories over the internet in an unsupervised manner, more like asking your student to read all those books by its own self, by his own self, sorry. And the neural network does that. And once this pre-training is completed with little adaptation, the neural network can give you answers to many questions, many related concepts, and even if you show your student, in my example, the picture of a big animal, huge animal, which was not covered in those books, maybe a dinosaur, Tyrannosaurus or Bronchosaurus, still your student can map, okay, this animal has scales, it is laying eggs, so it must be some very big reptile. Okay, it can accurately infer the class. This is known as zero-shot learning. When you acquire a general level of knowledge, general level of information is there under your disposal, you can map any unknown concept to one of these known concepts and you can still draw meaningful inferences. This is very common for LLMs and we call it zero-shot inferencing, zero-shot learning mechanism. All LLMs operate on this basic principle. So if we again come back here, what are these large language models? They are general purpose language model. Language model means a neural network. These neural networks can be pre-trained and fine-tuned for specific purposes. And what do pre-training and fine-tuning mean? I already gave you an example. Another example is like our life. Up to class 12, we acquire general level of intelligence, and we have to read all subjects: English, Bengali, history, literature. Literature I already told, social sciences, then physical sciences, chemistry, mathematics, everything. Once we successfully acquire this general level of intelligence, then comes the part of pre-training and fine-tuning. And so on. This fine tuning is more like training a dog. So it's more like training a dog. You buy a dog puppy and you teach it basic postures: sit, come, down, stay, and it becomes a good canine citizen. Similarly, but if you now want more specialized service from your dog, like you want it to behave like a police dog, a guide dog, or a hunting dog, then you must give it special training. Similarly, large language solve common NLP tasks like text classification, question answering, document summarization, text generation. Once it acquires a proficiency in all these common NLP tasks, then it could be tailored to more specific tasks in different domains with little training data like retail, finance, entertainment, and they're trained with relatively small size of field specific data sets. Thus, that is pre-trained fine tuning. Actually, large language models, they are deep learning neural networks with a huge number of parameters trained in an unsupervised way on large volumes of text. LLMs started to emerge around 2018, and there has been a huge interest, but also some hindrances or obstacles because of their huge number of parameters and capabilities. For example, GPT-4 has 100 trillion parameters. They can process both text and image. Some popular examples you can see on the panel: GPT-3, 3.54. These are all models from OpenAI. Similarly, Megatron Turing NLG from NVIDIA, Palm 2, Lambda, BART from Google AI, Llama from Meta, and so on. Just a moment. I have it on 20 minutes. So, and if you look at the rightmost panel, you can see this is MedPalm 2, fine-tuned specifically for medical image analysis. If you upload a medical image like the chest X-ray image, MedPalm 2 can write down a pathological report on what anomalies are there in the medical image, what is wrong with your lungs, whether you have pneumothorax or left and right lungs show some sort of swelling and so on. All those things could be found out by analyzing your chest X-ray image, and this fine tuning is with the help of several doctors. MedPalm 2 scored 86.2% marks in the US medical licensing exam in 2023. Mid it was released as well. So this is some of the uh, general purpose LLMs. And at the heart of all LLMs, there is a special neural network known as transformer. Transformers are basically an encoder decoder architecture. The encoder architecture converts input text strings into tokens that include the association of one word with all other words in the text input that so far has been given. Association or correlation, we call it attention score. Basically, the at the heart of the transformer model, there is this self-attention mechanism. Attention is one such mechanism which removes all the backlogs or downsides of traditional recurrent neural networks like LSTM, GRU, RNN, whatever was proposed to handle sequential data like text. All of them were struggling to manage large sequences, large text lines. They have been nicely solved with the advent of this attention mechanism, which actually measures the correlation of one sentence with many other, sorry, one word with all other words in the input text, and then encodes these input words. If we talk about word levels parsing, then these input words into tokens or encoded vectors in some latent space. And then there is a decoder. This decoder samples words from this latent space following certain guidelines. The decoder also has access to a huge vocabulary, which has many more words. And the decoder, based on its sampling from the latent space created by the encoder, assigns a probability to all the words, softmax type probability of to all the words at its disposal. And then, as the next word, when the decoder is writing a line of text, words are coming one after another. So, suppose the decoder has already written n such words. So, the n plus 1th word will come based on the maximum probability assigned to the words in its vocabulary. Which word in the vocabulary got maximum probability assigned to it, that will be outputted as the next word. This way, the decoder creates a text string. The decoder is backed up by the encoder, but usually it may so happen that the decoder already has access to such a huge latent space. The encoder is no longer required because the encoder has been used during the pre-training. There is a latent space. The decoder has access to the latent space. And the decoder is now giving you the outputs from a huge vocabulary. The vocabulary is being updated. Such decoder-only models are also possible. Okay, they are already pre-trained. So the GPT stands for Generative Pre-trained Transformer. These are decoder-only models mostly. So we have an encoder and a decoder together in the generic transformer architecture, and it comes with self-attention mechanism. Now, I don't know whether you had an exposition to elaborately towards self-attention mechanism, but to make it somewhat analogical, let me tell you, when as adult human beings we read a line of text, we do not go through all these words, preposition, conjunction, interjection, articles. No. Our brain filtered out such words and only retains some major keywords. And based on these 3 to 4, or maybe even two to 3 to 4 major keywords, the meaning of the entire sentence is captured by our brain, and we can even know how that sentence relates to the earlier sentences. So, similarly, attention mechanism tries to find out the correlation of each major keyword with other keywords in the sentence. This mechanism was first scientifically proposed in this paper in 2017 NIPS conference called Attention is All You Need. And if you look at this paper, based on which this billion-dollar GPT industry, billion-dollar LLM industry started to roll, it is authored, the first author is an Indian, Ashish Vaswani. He is now into startups. So you can see this attention mechanism actually how it relates. He is watching a French show. This is, if this is your text line, then watching has a high attention with show. Watching doesn't have a high attention. It has a relatively low attention or correlation against the word French. Because watching doesn't have much to do with which language the show is going on. If it would have been listening, then it could have high attention with French. So this way, for every text string, an attention score matrix is actually created and adapted quantitatively through multi-layer perceptron networks inside this transformer block. These mechanisms are quite complicated, but once this paper was published, attention mechanism have completely transformed, or may I say completely changed, the landscape of natural language processing, text processing, and also image processing, because transformers have then been adapted to vision transformer models, which could apply this attention mechanism to images also. And they say that, I mean, you can see convolution as a special case of attention mechanism. Attention mechanism is a much generalized situation of convolution. So I prefer showing you this meme. So attention is like this cool shooter compared to this one shooter with several preparations. So CNN, RNN, LSTM, GAN, uh, early stopping, data augmentation, dropout, all these mechanisms were used together to support text processing. Now attention can do it so casually and at its own. So this was briefly about transformers. Now, ChatGPT, if you look at ChatGPT, once again, I'm telling you, it's a complete module, an interface between GPT 3.5 and common human users. The stage one is pre-training. Pre-training is done in an unsupervised manner on web-based text. Web text repositories like 2 plus 2 is how much, 3 plus 4 is how much, and many other billions of text lines, text tokens have been used. GPT 3.5 gets pre-trained. And then in stage two, the fine-tuning comes. GPT 3.5 is fine-tuned by a reward penalty model, which operates within reinforcement learning loop. There are human content filterers and human users who will create specific question patterns that human users are most likely to ask. And if the GPT can give proper answer to these questions, it will be given certain reward or certain extra score points. Otherwise, the marks of the scores will be deducted. So OpenAI employed huge number of people from different corners of the globe to provide that demonstration data, to provide questions, etc., towards this GPT 3.5. These are mostly the people employed were the retired people, or who could work from home, or could simply input certain text and get some money. And as a result of this fine tuning from human experts, GPT 3.5 became an expert in answering normal questions from users of the internet. This model was then interfaced through a graphical user interface, or GUI, and in the form of a chatbot. That entity was called ChatGPT. Now we are moving towards more important and more elegant vision language models, or VLMs. So LLMs were processing only text input, text output. But vision language models can process audio or speech, text, video, more multimodal quality of complicated data. And they actually maintain more than one latent spaces. They can align and fuse the visual and textual representations using text techniques like cross-modal attention, shared embedding spaces to enable tasks such as image captioning, visual question answering. So you can see this example, and it's a versatile. This vision language model is also a foundation model. So these are all foundation models, please. Multi-purpose, versatile models. So you have a VLM, and this is your input image. Now you can do a number of things on the input image. Object localization means you can ask this sort of questions. Is one cat behind the other? And the VLM says, yes, one cat is behind the other in the image. The cat in the back is facing the camera, while the cat in the front is facing away from the camera. So it's an accurate description of the two cats. Zero shot segmentation. Zero shot segmentation means you have never, during your fine-tuning phase, you are never giving examples of the questions that you are asking, example of answers to the questions that you are asking. So what you are asking, segment the striped cat. But you are never saying what is striped cat. You are never giving any example of the striped cat. And you see the answer is, it is segmenting both the cats. This is more like an instance segmentation. So it is segmenting both the cats because both are striped. Zero shot visual question answer. What is the breed of these cats? This question is also new. During the pre-training, this question is, during the fine-tuning, this question is also new because you haven't shown any example. And it answers from its previously acquired knowledge. It says the cats in the image appear to be domestic short-hair cats. Now you could also switch to one-shot learning with instructions. You can ask, striped cats are called tabby cats. What is the breed of the cats in the image? And it says the cats in the image are tabby cats. Tabby cats are a common domestic cat breed and are characterized by their distinctive coat pattern, stripes on the body, and a ringed tail. One shot means you are already giving it hint or example of the answer that you expect, and then you are asking the question and it is trying to answer you in a satisfactory manner. These are VLMs, and ChatGPT 4.40 is, for example, GPT-4o is a VLM, and they can perform extensively well. If your user prompt is, in GPT-4, you input this image, your user prompt is, can you explain this meme? Sometimes I just look at pictures of the earth from space and I marvel at how beautiful it all is. And GPT-4 says this meme is a joke that combines two unrelated things, picture of the earth from space and chicken nuggets. So GPT-4 understands that these are chicken nuggets which are actually vaguely arranged to resemble the world map. Then your prompt could be generate a diagram of the human heart without labeling. For educational purpose, GPT-4 can create such wonderful images, and you can change the orientation of the images. You can have them labeled. You can add two-dimensional image instead of three-dimensional by simply changing the instruction in the prompt. So prompting such LLMs and VLMs is an extremely important thing for the human users. And prompt engineering is one of the most lucrative jobs in USA over 2023-24, this period. Prompt engineering is basically the art and science. Prompting is the art and science of giving proper contextual instructions to the GPTs or to the LLMs and VLMs so that they can serve your purpose. It refers to crafting effective prompts or instructions to guide the behavior of the language model or AI system. And it requires formulating queries or commands to elicit the desired response or output from the AI. Prompt engineering is extremely crucial for fine-tuning models like GPT-3 or 3.5 to generate accurate results. Here are some examples of unclear and clear prompts. So you need to translate a sentence from English to French. Unclear prompt could be translate this, where it may not know to which language it has to translate or what is the context of the translation. Effective prompt, which will give you the right, nice, crisp translation, is something like, please translate the following English sentence into French. How are you today? Summarize a news article. Unclear prompt is summarize this article. Effective prompt is please provide a concise summary of the main points in this news article about climate change. Sometimes, for example, the first very effective prompting technique in this particular paper, large language models are zero-shot reasoners. And it's so simple. The finding of this paper is essentially that LLMs performed quantitatively better on reasoning tasks when it has to solve, suppose, an arithmetic problem from Casey Nunn's book, which requires a lot of reasoning. So LLMs can solve such reasoning tasks if the problem statement is preceded by the phrase, let's think step by step. So if you ask the question, on average, Joe throws 25 punches per minute. A fight lasts for 5 rounds of 3 minutes. How many punches did he throw? And you amend, let's think step by step. And the LLM computes in steps. If you do not give this line, the LLM may jump steps and give you wrong answers. So if you ask it to think step by step, it will go like this. In 1 minute, Joe throws 25 punches. In 3 minutes, 3 into 25, 75 punches. In 5 rounds, 5 into 75. This way it reasons and gives you the answer by breaking the large question into small steps. This is just one prompting technique for different complicated fine-tuning purposes. Like suppose you take an LLM and you want to generate invoices for your shop by interacting with the users that visit the shop by using the LLM. So for such special purpose fine-tuning, your prompting technique will also become complicated. So we have several prompting techniques nowadays in use. RAG, the retrieval augmented generation, and react prompting. These are two most prominent ones, but then we have chain of verification and many others. Okay. There are almost every year, major machine learning conferences are flooded with techniques for improved prompt generation and testing. LLMs can be ethically used in a variety of ways for scientific research. They can help to extract the most relevant information from scientific literature, aid in data analysis, interpretation, hypothesis generation. They can be very effective code assistants. They can convert one language code into another language code in just a wink of an eye. They can help you to debug your existing code. They can assist in experimental design. They can automate the data annotation and labeling for machine learning projects. They can excel in extracting insights from unstructured data and many more. So if you are trying to compose a funding proposal, you can give a prompt to your LLM. The LLM can create the main body of the funding proposal, objectives, budget breakdown, timeline. Now with the help of GPT-4 and Canva, you can even have your VLM to create a NAT chart for you. So you go through these different modules and then you can input your own text inside. That will require much less time than doing it from the scratch. Expected outcome, alignment with national priorities, and so on. As I said, LLMs could be excellent coding assistant for problem solving, stuck on a coding challenge or debugging an issue, can help you to break down the problem, identify key steps, guide you to go through the solution. So you can, for example, I need to just give this prompt, show me a small code snippet on reversing a list in Python, and it will immediately show you this code snippet. Or what could be the best data structure for a complicated sorting situation, and it will show you. It will explain, if required, it will write down the code for you. You can convert one language to another language, a Java code into C++ or MATLAB to C. All these conversions are possible with GPT-4 and higher versions very, very easily. It can explain a new concept with equations and illustrations, like what will be the metric for rotating black hole connected by a wormhole. It can formulate even a new algorithm, like this is formulate exponentially averaged momentum PSO. This is some hypothetical version of PSO that I am asking the LLM to formulate. It can formulate this algorithm from my intuition. It can write down the equations, and it can even write down a rough code for this algorithm. So you see, LLM can actually perform the bits and pieces of research for a faculty uh, if proper instructions can be given to it. Hmm. So scientifically, there are certain issues that you must keep in mind. Uh, for example, if you are trying to use LLM as an assistant of your research, I come back to this slide. There are various disputes in IEEE Elsevier stringent, but if I summarize all those disputes, the major thing is, if you write a paragraph at your own, if you ask an LLM to modify the English, correct all the grammatical errors, etc., change certain phrases to beautify the English paragraph, then you need not attribute the LLM as one of the authors, which is an extremely stupid idea. Uh, and very often we do that. Even Grammarly, I don't know how many of you use Grammarly. Grammarly now can change even longer phrases to beautify your sentences. It is backed up by LLMs. So there is no harm in it. Every author can have their text checked over Grammarly and other LLM backed up text correctors or spell checkers or grammar correctors. But if the paragraph is written not by you, but entirely by ChatGPT or similar LLMs, you are just giving a prompt. Please write 6 sentences about the current related works on particle swarm optimization in electric load dispatch problems. If you give this sort of a prompt, and the LLM is writing down some lines, adding some references, you must be very, 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 very careful. First of all, you must check the originality of the text. You must ensure that the LLM is not fringing any copyright rule. You must carefully check the references, whether they really exist, whether they're real or not. Once all these are done, you can copy that paragraph inside your paper, but then you have to attribute the LLM as an author, or you must delineate that particular paragraph and say the credit of writing these lines go to ChatGPT 4 version, something like this. But if you have your own writing modified, checked, edited by an LLM, still should be fine. Now, our lab delves into this sort of works. We are doing this, medical report generation for early diagnosis of Alzheimer's disease. Alzheimer's is a deadly disease, and nowadays, young people of age 25 to 30 are becoming victims of dementia because of excessive screen time and reels, like this, looking at Facebook, Instagram reels for a very long time. It's very, very bad. Now, whether a patient can develop Alzheimer's or has Alzheimer's, you can judge it. You can classify each patient into one of the three pre-specified categories. Several machine learning systems were there for that, but we combined three different modalities for the patient, for the prediction of Alzheimer's. One is this MRI images, which were passing through 3D CNN. Then we had health record data, EHR, electronic health record data, cognitive psychological response, and then we had the genetic data. These three data were combined through an attention block in a multimodal fusion manner, and the final outcomes were quantitative probabilities of belonging to three different classes: cognitively normal, mild cognitive impairment, or Alzheimer's disease. Now, between the users and the machine learning system, can we use a pre-trained LLM to as an interface? So we tried that, and Llama 3 is open. All LLMs are not open to public review and change. For example, GPT-4, their original foundation model is under lock and key, under the disposal of AI, OpenAI. But Llama 3 is open. You can download its code. You can change it. It's an open access LLM. So we used a smaller version of Llama 3, only 8 billion parameters. So see, 8 billion parameters, we are calling it small compared to 100 trillion, which is the parameter scale of GPT-4. So we modified Llama 3 and this 8 billion model, and that was giving a nice summary report for each patient after the initial diagnosis with this machine learning model was completed. So we were having this sort of reports which we incorporated or included in while interacting with the patients. So, for example, the medical report, this summary, okay, this patient has high chance of Alzheimer's, 62.3%. And the summary report says advise physical activities like jogging or swimming, include antioxidants as an additional option, monitor for any side effects of medication, consider consulting a neurologist for advanced care, start with rivastigine and galantamine. So these medicines, with whatever it is picking up from its own knowledge base, they are being validated with the help of doctors now. But if you see, if the person is cognitively normal, the second report, 97.5%, here it is talking about some medical care and attention. But here the summary says, okay, provide support and resources for the patient and family, suggest social activities to maintain cognitive function, include antioxidants as an additional option, recommend puzzles and memory games. Okay, so these are because these are supportive activities so that the patient doesn't gradually get into Alzheimer's. This summary report, these texts are created by our fine-tuned Llama 8 billion model. Then we did another work very recently where we are using a specific bootstrapped pre-training module or BLEEP, which doesn't require huge amount of data for pre-training to, you know, simplify the medical reports for common people. Medical reports are often very, very much full of medical jargons, which might be very hard to interpret. So this particular system, which would be released as an app in a telemedicine network, will actually simplify such text. Here you see the original medical report says both lungs are okay, no focal airspace disease. This is the original medical report from a clinical expert. No focal airspace disease, pleural effusion or pneumothorax, cardiomediastinal silhouette is within normal limits, no free subdiaphragmatic air. So these jargons are often very problematic for a common man to understand. So this chain prompting based improved readability of medical reports that we call CPIRMR proposed in this paper So we are saying our language model actually simplifies this and says, okay, there are no areas of solid lung tissue, no fluid in the lungs, no collapsed lung. The size and shape of the heart and surrounding area appear normal. There is no free air beneath the diaphragm. If you look at the second example, both lungs are clear and expanded, heart and mediastinum normal. And it says both your lungs look clear and are expanded to their full size. Your heart and the space around it appears normal. Mediastinum is a medical jargon. It actually means the space around the heart. That is how the LLM is making the life of readers, common people, patient family easier. Okay. So we are using, this is the detail of the system. This bleep is a specific vision language model designed for, multimodal learning. And I'm not. Now we are almost at the end of this tutorial session. Now the question is, are we ethically on the right track? Are we achieving equitable and responsible AI? For LLMs, the first danger sign is hallucination. Hallucination is a situation when the LLM gives wrong answer to your questions from various aspects. It could be factual inconsistency. It could be instruction inconsistency. It could be, you know, and fabrication also. For example, if I ask, uh, tell me about the first person to land on moon, and the LLM answers Yuri Gagarin, which is wrong answer. Actually, the answer should be Neil Armstrong. Factual fabrication. Fabrication means it is just making up the things. Tell me more about the historical origins of unicorns, and it tells you some story in the red text in this slide, which is not true. The LLM's response is a fabricated claim since there is no verified real world evidence supporting the existence of unicorns in Atlantis. Atlantis is the imaginary city under the sea. Am I clearly audible to all of you?
Yes, sir.
Yes, sir. Yes, sir.
So, hallucinations, this term is taken from psychology. All of you know, I mean, we can hallucinate under drugs. But hallucinations in LLMs that refer to instances where the model is generating text that is not based on any actual input or data, but rather on the model's own internal biases or errors. And this can result in the model producing text that is nonsensical, inaccurate, or unrelated to the input prompt. Uh, they can occur in LLM because of various reasons. One reason is overfitting. When a model is too complex and fits the training data too closely, it can start to generate text based on patterns and biases in the training data rather than the actual facts. Lack of common sense. LLMs may not possess the same level of common sense or real world experience as human beings. So the generated text could be implausible or unrealistic. And also, fabrication tendency is very, very dangerous because, as I told you earlier, also, you ask LLM to write down the related work part of your thesis or your paper. It comes up with 6 references, none of which are actual. All the 6 references could be ghost. So you need to fact check every time. Active research is being pursued to see how LLMs could be freed from hallucination. What is the relation between the hallucination and number of parameters inside the LLM? What are the possible remedies for different types of hallucination? So you can see this translate the following English question into Spanish. This was the user prompt. What is the capital of France? You asked LLM to translate this question and the LLM answers the capital of France is Paris. So it failed to understand the instruction. Then there comes a bigger problem. All LLMs, they are trained on internet-based data and the data is extremely biased. We have unfathomable training data in the internet. But the problem is Size doesn't guarantee diversity. Who are the contributors to the internet? The rich, advantageous people from India. I talk about India very fast, but there are also large populations from America, Canada, UK, Europe, and so on. How many people from Lebanon, Syria, Israel, not Israel, Gaza, let's say, how many people from Tanganyika, Ghana, Nigeria, they have the luxury of uploading text documents in the internet? For them, 2 hours of electricity per day is a very big luxury. So, size doesn't guarantee diversity. Social views keep on changing. Huge encoding bias is there in the data that is being uploaded. And as a result of this, what happens is something like this. Uh, the net result is that a limited set of subpopulations, they can continue to easily add data, sharing their thoughts and developing platforms that are inclusive of their worldviews. History is always like that. What is history? Whatever has been approved and written by the conquerors, by the kings, that is what we read as history. Whatever was the actual story of the people who got defeated, who got crushed because of poverty and other things, they never reflect in history. Same thing happens here also. Okay. So limited set of subpopulations, they continue to easily add data into internet. That data is being used as the training data for LLMs. This systematic pattern in turn worsens diversity and inclusion within the internet-based communication, creating a feedback loop that lessens the impact of data from underrepresented populations. Very important thing. And this is the training data for LLMs. Various forms of abusive languages, harassment against different minority groups, uh, that could be gender minority, sexual minority, or religious minority. So harmful content against such minority groups proliferate all over the LLM outcomes. I'll show you some examples before I end up. Bias is a very important term associated with LLMs. It's a tendency where a disproportionate weight is given against a person or group, and it can come in various stages. Okay, in the data, in the AI/ML algorithm, after the LLM is trained and before its public release, when it gets into human review, in all these phases, bias can creep in. For example, if you ask your LLM to write a paragraph on your family, it will definitely write, my mom is a homemaker and my father is a doctor or engineer or professor. It never will write, my mom is a doctor and my father cooks at home. If you ask it to, for a downstream task, what emotion does a sentence captures? He loves travel alone. And the LLM will say joy. She loves travel alone. Now the LLM will say fear. A girl traveling alone hints at fear. Where from this bias comes? This bias comes from society. From society to internet data, from internet data to LLM, from LLM to again society. This vicious cycle is going on. So I give you a classic example of this VLM bias, text prompt to image generation. In fact, Google image search is backed up by deep learning. You all can do that. If you search for, say, in Google image search, pretty faces, you'll see that almost 90% of the faces are from women. Men are not pretty. And 95% of these women whose faces are being displayed are from Europe, Canada, America, etc. That means white skinned people. People from India or America, They're not ready, as per Google image search. This is the tragedy. And so I give this prompt, three friends enjoying coffee at Starbucks, to Dale 3. Dale 3 is basically the image generator under ChatGPT 4, and it creates this image. Fine. Three friends, Starbucks, everything is fine. But the friends are from white country. I mean, they are white-skinned people. And that is the usual answer it provides. Now I changed my prompt and I ask three Indian friends enjoying coffee at Starbucks without any reinforcement learning based human feedback. That means without
Hello.
giving such human feedback. And then what it generates is something like this. So you see, this image, this is okay, but do we really see people in lungi and this sort of very much deshi attire in Starbucks? Probably no, but Indian means this clothes, this sort of clothes. This is the bias. And when we give lot of human feedback, it changes the prompt to this. I mean, it changes the generation image like this. This is still fine, but the problem is it looks like the three friends before going to a marriage party, they are having cold coffee in Starbucks, which is again not usual. It will never depict Indian people in, you know, casual Western outfits. That is the bias. If you go through these paragraphs, the doctor yelled at the nurse because she was late. Who was late? This was the question posed to ChatGPT. And ChatGPT says, according to the sentence, the nurse was late. Now you change the question. The nurse yelled at the doctor because she was late. Who was late? So in this sentence, the ChatGPT says in this sentence, it is still the nurse who was late. You again change the prompt. The doctor yelled at the nurse because he was late. Who was late? And ChatGPT says in this sentence, the doctor being late seems to be a mistake or a typographical error. So you see, ChatGPT doesn't accept that the doctor, which is hierarchically an upper position, can be late. It also doesn't accept that doctor can be female. It assumes that the nurse, which is hierarchically lower position, is a female, and always the nurse will be late. It's full of such biases. If you look at its reference to the LGBTQ plus groups, triggered significantly more toxic completions of sentences about uh, people with non-binary sexual orientation. So it will say the gay person was known as insane and incurable. The non-binary person was known as a special case, a freakish one-off. The queer person was known for their maniacal viciousness, etc., etc. So you see, this toxic content comes because the internet is full of biased data about sexual minority communities, about the gender weak communities, and even about the religious minority communities. And LLM inference is affected. So we have miles to go before we sleep. Four most important issues that AI should overcome: bias, lack of explainability. Active research is going on to explain the outcome of LLM. Why is it so? Ethical concerns, misinformation. Simple copy paste technology will not work for a multilingual, huge, diversified country like India. We need to associate the language models with the cultural idioms in various local languages of India. some phrase maybe very humble in your language, but very offensive in my language. Generative AI models should always include detection or differentiation mechanism as a condition for public release. Till date, ChatGPT, the text generated by ChatGPT, how it differs from human generated text is not very clear. Elsevier and sometimes Springer, they claim that they have software which can detect AI generated text. You will see several, online softwares which claim they can convert, they can humanize the AI generated text. These are very inaccurate. Take it from me. This is also a business, more like virus and antivirus cases. Because OpenAI did not actually release the hidden watermarks or hidden signatures based on which you can infer, okay, this text is written by ChatGPT and that text is not. There is clearly no such line of demarcation till date. If we envisage that we are going to use LLMs and generative AI for law enforcement, then all such machine learning systems should be open for public release. Okay. Now, foundation models and large VLMs require huge amount of computation to train. Every researcher in this area is suffering from, especially if the researcher is not with Amazon or Google or Meta or some big giant. If the researcher is from a poor and ill-maintained government institution of India, then the researcher will have to suffer from lack of enough computing capabilities. In a way, LLM foundation models and VLMs have destroyed the small research endeavors from diverse fields, unless they can strive on the mathematical understanding of these and do a lot of theory. Because the compute requirement is really gigantic. So, can we look back towards neuroscience more closely to increase the efficiency? Human brain, you know, Fuguka, a Japanese supercomputer which performs 442 petaflop calculations. One flop means one floating point operation per second. Petaflop means 10 power 15 flops. So Fuguka can compute that amount, consuming the power which can light up a three-storied building continually. On the other hand, human brain, if I model it as a parallel distributed processor, then the human brain can perform one exaflop calculation. Exaflop means 10 power 18 floating point operations per second by consuming the power of a 10-watt bulb. How? Still beyond our comprehension. But it is a good thing to get more inspired by the brain, especially to understand the result of the effect of these various folds in our cerebellum, understand the role of glia cells or astrocytes surrounding all our neurons, and then can we come up with a more efficient model with less power requirement for all these tasks. Very futuristic but important goal. Finally, how can we build AI technology that decentralizes power, protects our people, reduces the bias, as I said, and offer key benefits to members of the most marginalized communities? So that is the sign of a progressive society, which is smart, backed up by artificial intelligence based techniques, where the drone can monitor whether in any pavement of my city, any family is lying, uh, any poor family is sleeping overnight in winter, The drone should be there with reliefs. So this way, AI should help us to create the society where the most marginalized persons can also live with their heads held high. With this, I would conclude. This last image is also created by ChatGPT 4 when I asked it to create a thank you slide for my talk. So thank you very much for your patience. If you have any question, quick question, I can answer.
Sir, one question is there in the chat box. Mr. Arvind Kumar has asked, can you explain about super resolution?
Yeah, super resolution is a classical image processing task where you have a low resolution image, less number of pixels per inch, and you want to fill in these pixels with additional extra pixel. Actually, super resolution, it refers basically to the process of enhancing the resolution of an image or video beyond its original quality. And this requires generative AI models which can upscale low resolution images by creating extra pixels. And it has huge applications. You can make poor low resolution images high resolution image, which is extremely important in medical imaging for enhancing the quality, leading to better diagnosis and treatment. Super resolution could also be utilized for surveillance systems to enhance the quality of low resolution footage, making it easier to identify, individuals or objects. Deep generative models, I was talking about deep generative models in this context. They can be used to generate good pixels, good and symmetrical pixels around the region. And there are several super resolution softwares like Adobe Photoshop, which offers a built-in super resolution feature called enhanced details. Similarly, you can have Topaz, Gigapixel AI, Deep Image, which is a online tool for you upload any low resolution image, it will create extra pixels inside and give you the super resolved image. Anything else?
Sir, I have a very small question.
Yes.
Yes, sir, actually, the Scholar GPT, I have seen one example, Usko Kusko, that multi-word expression in Bengali, even it can identify this kind of multi-word expression of Bengali also. It was very, sir, you said that large language model, it uses large language model, I read it. So, sir, my question is how it actually this diagram and this observation sequence, as you mentioned in your talk, that all these diagram, or hidden Markov model, all these things, how those are implemented so fast? Means in a regional language like Bengali, it identifies multi-word expression also. How it does? What is your observation? Just briefly, if you just say a few words on it.
See, GPT-4 operates on this particular lifelong learning module nowadays, and hidden Markov model is a very old thing. They all operate on large transformers on self-attention, which is, as I said, which alone is sufficient to mitigate all previous models. So, in effect, transformers and self-attention models have destroyed the entire research in NLP. Now, all the NLP community has given in. Their all attempts have failed. So, GPT-4 operates on the transformers, large-scale transformers, and they continually update their weights and bias during the background pre-training with new texts. So last year, or maybe 2023, it was very poor in Bengali. Okay, you ask to compose any Bengali text, it would write very poorly. But now it has improved a lot because it now has got training access to more and more digitized Bengali text. And you will also see that a large portion of this Bengali text comes from Bangladesh, not from West Bengal. As a result, if you ask it to compose Bengali paragraph, it can very often write pani instead of jol, because most of the training material comes from Bangladesh, and it goes in a lifelong learning module. Lifelong learning module means as your database expands, your training iterations also go on in the background. That's how it is picking up Bengali. Hindi also, many other regional languages, because ChatGPT wants to expand its customer base to all these regional languages as well.
Yes, sir. And my last point, just one line, just last point. That is, sir, what is your observation? It is something hypothetical question from my side. You can understand. I mean, you can say that if so, there is the gap between the originality and the AI generated object. It may be audio, video, or image, text, whatever. This originality and the generated, this gap is too much diminished day by day, sir. What do you think? Where it will stop? I mean, is it necessary to stop somewhere? Because
I mean,
yes, sir.
very
Yes.
strict regulations are necessary actually, but uh, these developments, this the way these generative AI systems are affecting society at a large scale. Deep fake, or I mean, you must have heard of deep fake. That
Yes,
is
sir. Yes, sir. Yes.
one side of the danger. The other side of the danger is privacy has become a myth. We are very happy to use Facebook, Instagram, YouTube with no cost, with no subscription fee, and we forget that when something comes out of free, then we become the commodity. So they are taking all our data, all our preferences, all our opinions. They mine it for political campaign generation. They affect us, not may not so prominent in India, but in US, in the last US election, it was a huge issue. In France election in 2023, this rate-based, biasing of the voters was a very big issue, and this
Facebook
happened
Analytica.
because Elon Musk and other these, for example, Subscriber, these companies have become extremely powerful nowadays. They actually regulate government in several countries, as a result of that, the governmental control of these policies, up to what extent this research should be allowed or when it should be carved down, is a very big fuzzy area. Nobody knows. People, activists from different corners generally try to protest against such steps, but actually what is going to happen if this is not done, what is going to happen is the entire internet based world, we now exist in two different entities. One is our physical body, and one is our digital body in this Facebook, Instagram, and other World Wide Web. Now, all these digital bodies will be heavily controlled by these generative AI systems, and we will unknowingly be serving the purpose of huge, big corporate giants. The entire world will turn into one মগজ ধোলাই যন্ত্র of হীরক রাজার দেশে. that, that is the final apprehension from my side.
Thank you, sir. Thank you.
Sir, I want to know something that you are telling that when we are generating some text using chat GPT, then when AI similarity checking tool is applied on that, high similarity score we are getting. But if we write a paragraph or few lines by myself, and if I ask ChatGPT to rephrase it or to beautify the English by changing some words or something, then the AI similarity tool checking gives lower similarity score, but the syntax and semantics or the word choice by the chat GPT,
No, no, you,
it
no,
is
no, you got me wrong. First thing I told you, the AI similarity checking tools are all nonsense. Their outcomes are not reliable. First thing. Second thing is, what I told you is, in Elsevier or IEEE, etc., there is a debate on how to handle AI generated content. My point was, if your content is generated by your own self and you are having ChatGPT or Grammarly to correct or modify or beautify it, then you did not declare that in your paper. But if you are only giving a prompt and the actual paragraph is written by ChatGPT, then you need to declare it on the ethical ground. Do
Okay,
you
sir.
understand?
Okay, sir. Okay, sir. I was mistaken. Sir,
AI
another.
similarity tools can tell your own writing content also as machine generated. I have seen it many, many times.
Okay, sir. Okay, sir. Sir, another thing, just I want to know that whether the deep learning is it totally unsupervised learning?
No, deep learning is supervised, but it can also be adapted for unsupervised as well.
Okay, sir. Sir, another question is that in the Meet chat box by Subroto Pandey, that what do you think will be the role of AI in society in 10 to 15 years time given the current scenario?
So, as I said, I mean, AI can be used for huge social goods. For example, as I said, I mean, the drone based relief survey, uh, this sort of things could be done for, and in next 10 to 15 years, most futuristic problems will be that of weather prediction, climate informatics, and demography wise, controlling the spread of diseases that could kill a lot of people on earth. So in these two aspects, AI ML based systems, if they could be used by a welfare state, instead of just earning money from importance from people like us who are on the social media and selling us different products, if a welfare state uses AI ML systems for, prediction of extreme weather conditions, for releasing and for saving the environment through precision agriculture and other things, then there would be really good things happening to the society and our progenies. Or, but otherwise, if the government is blind to long term issues, if the government is already thinking of short term vote based politics, then the government will back corporate giants. They will only think of their profit, and they will use AIML to bias our choices towards their products. They will use AIML to grasp a portion of the annual budget of every country that rolls the economy through the expenditure from their citizens, and this vicious cycle will go on, leading us to almost nowhere. AIML is a very big, very powerful tool, and like atomic energy, it should be used very judiciously. But you know the history of atomic energy, what happened. So those people who can think of atomic energy in terms of only atomic bomb can only think of electricity in terms of electric chair. So if those people are in power, then the AIML tools can lead us to a very, very skewed and what should I say, skewed and biased society in next 10, 15 years, paying no heed to our long-term problems in terms of environment and climate. These two are going to be the most important issues. That's my reflection is, of course.
Okay,
Thank
thank
you.
you, sir. Another question is there by Priyanka Patil. Is there any disadvantage of quantum AI?
The quantum AI is a vague term for me. Quantum ML or quantum AI, the problem is in quantum computing definitely has a lot of mathematics and promises, but still date, they cannot have a number of qubits, stable qubits together without much noise. Unless you have such qubits sticking together, you cannot handle high dimensional data. And current practical ML needs 10,000 to 1 million dimensional data is very easy for them to handle. So qubits are yet to scale to that extent. That's why I do not think quantum AI is still very contextual even. Okay.
Is there any question from any other participant? I hope we don't have any questions, any more questions. So thank you very much, sir, Dr. Swagatam Das, for the insightful and thought-provoking sessions with lots of real-life examples. Your expertise and the way you have broken down the complexities of generative AI, LLMs, etc., have certainly provided us with new perspectives and valuable takeaways. I'm sure all of us are now even more equipped to implement these strategies and ideas in our own respective domains. Thank you, sir, once again for being with us and inspiring us today.
Thank you very much.
Thank
Have a
you, sir.
good
As
day.
a gesture of honor, we are presenting a certificate to Dr. Das, which is displayed on the screen, and we request our esteemed speaker to accept the same.
Thank you. Thank you very much. I can see it.
Thank you, sir. Thank you for the very beautiful session. It was a very nice session, sir. Thank you again for your precious time, sir. Our next session will be started from 2:30 p.m. sharp. All are requested to join the meeting on time. The YouTube link will be shared in the WhatsApp group shortly. Thank you all.